Okay, so we will start where we left off in the last talk. And we will start to talk about scene graph libraries, which are at our disposal. So there are many of them, and you will need them if you're going to cope with more complex scenes, because it's quite hard to write one on your own if the scene becomes very big. So you have some examples here. You have OpenSceneGraph, which is the one we will use. You have also something called OpenSG. You have something called Java 3D. You may remember from last lecture when we talked about object formats, this X3D format, in which there was a scene graph inside. So it's basically the same principle. So for our use, OpenSceneGraph is probably the best choice. So it's a heavyweight system. It uses plugins for loading models, for example 3ds files, which I talked about briefly in last lecture, as well as OBJ files, which we now know a bit about. It also has its own native format, .osg, which you can use to store whole scenes if you like. You can also get importing, exporting plugins for Maya and Blender, these 3D modeling engines. You have also lighting and cameras included, as well as both orthogonal and perspective projections, among other things. Now, the reason why we look at this is that it basically runs neatly on top of low-level rendering APIs like OpenGL, so it's perfect for our purposes. And of course, our 3D application then runs on top of this scene graph middleware. Within here you have some plugins, some core utility functions, as well as node kits, which I'll get back to in more details. You also have some documentation on this, which is, you know, a bit back and forth. It's not some really good information online, but there are books to be bought. But that's if somebody should be interested to know more in detail. But it's more your approach here would be more to learn about this by playing around with it. So basically these are the functional components of OpenSceneGraph. So everything is centered around the scene graph itself, basically the rendering elements, which is the tree or DAGs, which we saw in the previous video. You have some utility functions connected to it, which is, for example, traverses for the tree or graph that you have, which is built in. You also have some plugin possibilities, where you could load, for example, image files like JPEG, PNG, GIF. You also have plugins for files like 3ds, OSG. You also have another one for .obj also, of course, which we have been talking about. So they are basically loaded through this database loading plugin management, which is also, again, of course, connected back to this main scene graph component. You also have these node kits here at your disposal, which can do a lot of things for you. So they're basically listed here. For example, you have one node kit that gives you possibilities for interactive scene manipulation. You have some shadow frameworks. We haven't talked about shadow yet, but we'll do that next week, hopefully. You have some terrain rendering at your disposal, special effects framework, particle system. You even have flight simulators, and so on and so forth, animations. So it's really a powerful tool, this, if you learn how to use it. Now the core of this is basically, or at the base of this is basically a node again. It's basically a base class, and from this you can have for different types of nodes, like for example group nodes, which we talked about briefly in the previous video. And the group node typically groups a set of children in which these children, for example, be transformed in the same way. They can be switched between, which is then called a switch node. So you switch between children, like for example you would do if you would like to simulate a traffic light, where you have one node for red, one for orange, and one for green. You have this level of detail nodes, which basically is also a sort of switch node, but now it switches between children that has, for example, different resolutions of the same object, so that if you're far away, you would use an object with less resolution. If you're close up, you would use the same object with higher resolution. So it's a way of saving computational complexity. You also have light source, of course, which is in this case also is a leaf node defining light in the scene, as we saw earlier. You also have a geode, which is basically short, I think, for geometric node. It's a leaf node always in OpenSceneGraph, and it's basically a leaf node that groups drawables. So drawables are basically contained in this geode, and they are basically abstract base classes for drawing graphics. So they contain your geometry, you know, vertices, normal faces, texture coordinates, and so on and so forth. On the geode you also have these billboards, which is basically an opportunity for making sure that you always orient the drawables to face the viewer. This means that you don't draw things you don't need. It's a way of it's another word for backface culling, basically, where you're not interested in rendering things that are turned away from the camera. You also have inside this drawable you also have the possibility for drawing text. So you don't need to copy images from online, but you can get some quite nice text rendering using these engines. So here's an example of a transform node, which was mentioned here. So basically you start with the group node, where you gather all the geodes that should be transformed in the same way, and this is of course transformed by some input matrix that you will fetch. And all these geodes will then be transformed in the same way. And of course to these geodes you have these drawables connected. Note that these drawables are not... geodes are basically leaf nodes, and these drawables are basically features connected to this node. So it's not really a node of its own respect. Yeah, also this link given here, which you refer to all the time, is a nice presentation if you want a little summary about a bit more extensive summary on OpenSceneGraph functionalities. I will just touch quite briefly upon it in this video. So here is some typical pseudocode for how you basically make this hierarchy. So it's pretty straightforward. For example, if you want to make a new group, you basically use new group, and then you name it to something. Here's named root, and then just group root is equal to a new group, and then basically you have a new group node. Then if you want to connect a geode to it, a geometrical node, then you basically say new geode in the same sense. You name it, for in this particular case they named it leaf node, and then you define some geometry, basically saying new geometry. That is basically defining your drawable with all the vertices, colors, and faces. And then you basically, if you set that geometry, you name that some geometry, then some geometry dot set vertex array. You basically set the vertex coordinates. Set normal array, you basically set the normal coordinates, and in set color array you set the color values basically connected to this geometry. And once you set all that, you add this drawable, this geometry, to the leaf node, which is in this case the geode. So then you connect it in the way that is shown in this structure, right? And then at the end, you're basically adding this child to the root, and this only one child now. It's the geode, which is named leaf node. So you basically add that geode to the group just using this simple command. And then at the end you basically set the viewer, and that you do by viewer.set scene data, and then you set the viewer to the root of this hierarchy. Okay. OpenSceneGraph has some built-in primitives, and I will use this as a very simple example on how to build a hierarchy like this. So some of the built-in primitives are named in this exact way. So the red box here is basically box. This sphere is sphere. You know, cone, cylinder, and capsule. And to draw this, you basically use new shape drawable, as I show in the example here. So first and foremost, you have made a group and everything, but of course you need, so that you assume it's already done, but every time you want to draw something new, you make a new geode. And this time, instead of setting these things, vertex coordinates and normals and those sort of things, you basically say shape drawable, as I mentioned here, new shape drawable. And you call this still shape drawable in this case, just to give it a name. So new shape drawable is new cylinder, So you use the same name as I mentioned on the page here. This is the exact names for these primitive examples. And then you basically input the a vec3, which is basically the center of the cylinder. The second command here, which basically is radius. Here is radius 1, and then 4. This number 4 is basically the height. You could set to any height you like. And then you take this same cylinder which you made here, and you can set its colors by saying you know, this name dot set color, and then you have a vec4, of course. So R, G, B, and alpha. And we know from before that if you set red to 1, green to 0, and blue to 1, you get the magenta cylinder. So exactly the one that is shown here. And then once that is set, you add this drawable, which is now this cylinder shape, to the geode you initialized up here. So it's pretty straightforward. Now, before we end this talk, I will basically talk about some special nodes. I already mentioned the transform node. You also have the possibility for switch node, which is a way of switching between states for an object. You also have nodes for optimizing rendering performance. One is this LOD node, which is basically about providing different resolutions at different distances. And then you have this billboard node, which I'm not sure I mentioned. Yes, I think I did. It was this thing that oriented drawables to always face the viewer. And last, you have this nodes for presenting text. I will just give examples on switch and LOD. The rest basically follows in similar ways. So switch node is basically the same way as you make a group node or you make a geode. So you basically say switch S, you name it S in this case, and you say new switch in the exact same way as you did with the geode. And then you insert the children by saying s.insert child. Here it's child number 0, which corresponds to this gray node 8 over here. S.insert child number 1, which is the middle node here, and then s.insert child 2, which is node C over here. And then later you set this in an event handler, like you enable and disable other things, or similar to how you enabled or disabled things in OpenGL. You can basically set some single child on, or you could set several child on. Here's a single one. So if for example say s.set single child on, you will activate node B here, which is basically referring back to this number. So here you could use this switch to, for example, control a traffic light. So if this is red light, this is orange light, and this is green light, you can set this event handler later and make this light controllable from somewhere else, for example, or wherever you'd like. Right, and then you have this this level of detail node. So we're quite familiar with the fact that the human vision cannot really differentiate high resolution when something is moved at a distance. So the further away an object becomes, the less resolution it can have without us actually notifying a difference. So if, for example, take a tree or a leaf on a tree, you cannot really see it if it's far enough away. If you have a pine up close, you can see its needles and its branches, but if you move it 100 meters away, you don't see the needles anymore, for example, and you just see coarse outlines of branches. So, and also a tree far away will occupy fewer pixels usually. So the point is to save computational complexity, you will try to reduce the details for objects that are far away, and then have higher resolution when they're close up. And this you can do quite easily using this LOD node. So it acts like a switch node, only that it switches now between different child nodes based on distance to the viewer. And that you do by this LOD.set range here. So I'll just go to the direct example. So first and foremost, you have to initialize a new LOD, and that you do in exactly the same way as you made a geode or a group node. You just say new LOD, and you call it, for example, LOD with small letters or whatever you would like to call it. And Then, for example, to set this most high resolution child over here, this pine, you basically say LOD.addChild detailed node, and then you basically set the range between 0 and 10 meters in this case here. And then you have a not so detailed node, which is the other child to this LOD here. And basically it's the same thing, so you set range between, for example, 10 and 100 meters, and then for the farthest most here, which is of course of least detail, you can set that, for example, you know, very remotely, like between 100 and you know, 100 meters and beyond. So very similar ways of making these sort of things. Okay, so we're at base end for the talk now. I think that the point about this open scene graph is that you have to play around with it yourself, and I think it will be very useful for you in your assignment to use this, particularly if you do some more complex things. If your scene is a bit more, it's not that complex or have fewer objects, you may consider actually writing your own scene graph as well. But what you choose to do is really up to you. But I think that no matter which way you try, it will be very useful for you to consider these scene graphs one way or the other. But if you use Open Scene Graph, you should know that it's under constant development, so you have to really check for new features added regularly that will be out there. It's also used a lot in projects, so it's quite well known and well used. So it's nice to have that at your disposal. Now here are some resources for further reading. This is the article I recommended about this cube robot. And then you have this presentation on Open Scene Graph, as there are very few good online documentation on this Open Scene Graph. There are books, which is probably good, but I guess most of you won't be able to get that in time now anyways, if it's not already in the bookshop. And then you have this web page, of course, where everything is written, but it's not really a concise introduction. So you can go to this let me see, Open Scene Graph page is here, openscenegraph.org, and here you find, you know, for example, newest releases, you find documentations, which is, you know, not necessarily that good. You have some downloads, different releases, yeah, some galleries and some support and blah blah blah. So there's a lot of possibilities here, which you may click through. Here are some books on it that probably has a more coherent representation than what you find on this page. But anyway, here you find all the resources and the things you, for example, need to download, like unstable releases. And I mention this now because on Tuesday we're going to continue with labs. I'm not exactly sure how we will proceed with the labs, but at least we will post these labs online so that you're capable of starting with it, and then we'll come back on how we could do the questioning and answering to some of your questions and those sort of things later, as it's resolved what will happen in the future. But for now, therefore, I basically just placed the Lab 8 now online. So it's basically downloading and playing a bit around with Open Scene Graph. So you can find that if you go to the wiki, you'll basically find it on the side here. So here you have Lab 08 Open Scene Graph, and you click on that one, you have some instructions on what to do. So it's basically playing around with it a little bit. We may explain a little bit more on this later on Tuesday if you haven't started by then, if you find a way to communicate a bit more easily. But by now, this is what we have. And I also mentioned the situation down here, where you can basically now download the newest version of this lecture. And as I also said, the video you're now watching is of course placed on this YouTube channel. So we will announce next week what we will do. We will list what sort of lab we should go for and what sort of possible lectures it will be, and then how we will solve it. So yeah, that's it for now. So get back to you later when I know a bit more.